Hello friends, this is Durga from ITversity. As part of CCA Spark and Hadoop Developer Certification course, in this video I will be covering calculating aggregate statistics such as average or sum using Spark in Scala programming language. So there will be multiple videos on this. First we will start with totals, and then we will get into by group statistics. We not only cover average or sum, I will also try to cover max, and there are plenty other aggregations, and they can give anything in the certification. But so make sure that you are familiar with how to implement for a given requirement, not only for average or sum, but as many aggregations as possible. That being said, let's start with the syntax and semantics to get the totals. So you can go to the Spark 1.2.1 documentation. You will have access to this documentation as part of the certification exam. At the time of giving the exam, you will have access to this. In this, you can go to Spark Programming Guide, and here, if you go to transformations, there are many transformations which we'll be covering, but when it comes to totals, we will typically use count or reduce. So these two are the functions which we typically use to get the totals. So let me go ahead and demonstrate. And when you actually execute the actions, you don't need to invoke another action, and the action itself will make the script to execute as it follows the lazy evolution. As long as you do not invoke actions, the script will not execute. Until then, script will only be compiled and maintained internally, and when you actually invoke the action, the script will invoke and get the results. So I am launching Spark here, Spark shell, and as we by default the Cloudera VM will come with 1.3, but at the time of certification they only provide 1.2. So I have set up 1.2.1, and I have included in the channel how to set up 1.2.1 on the existing Cloudera VM 5.4 or 5.5. Make sure you set up 1.2.1 on the VM, and then give the explicit path to the Spark shell of 1.2.1, either by using master local or master yarn. I am using local because it is faster to start in the local mode. In certification exam, probably you might have to use yarn. So now the command line interface is started. So first thing is I want to create a variable val orders RDD. I just want to get the count of orders from the table. For that, first I need to read the data, and the data is in /user /Cloudera /scoop import /orders. This directory was created as part of scoop import effort. We have actually imported all the data from our MySQL database to here, and then hit enter. Now orders RDD will be mapped to this location, and then you can just say orders RDD dot count, and it will give the total number of records. It is 68,883. Okay, and now if you want to get the sum, instead of using count, you have to use reduce. So here, let's get the total revenue for the organization from our data set. So there is a table called order items. So I have to create a variable for order items RDD pointing to order items data. Here I have to say order underscore items and hit enter. Now order items RDD will have all the files from order items directory mapped to this RDD, and you can now say order items RDD dot count to get number of records from the table. It's order items RDD, And if I want to get the sum, first you need to understand the structure of order items table. For that, you can go to MySQL or Hive if you already have Hive table. In this case, I will go to MySQL. Cloudera is the password, retail underscore DB is the user I have used. Once I am in, I have to go to retail underscore DB database, show tables. You have order items here, describe order underscore items. So here I want to get the total revenue, and for each order item, the subtotal of revenue for each order item is under order item subtotal. So I have to fetch this fifth column and then apply a reduce function on that to actually get the sum of the revenue. So here what I have to do, order items RDD dot to fetch the order item subtotal, we have to pass, which means we have to do transformation. And if you go to the syllabus here, there are plenty of transformations. In this case, for this example, for each record we have to split by the delimiter, which is comma in this case, and fetch the order item subtotal, which is the fifth column after delimited by comma. So it is nothing but a transformation on each record. We are not flattening anything. For that reason, we have to use map function here. And map, you can pass the rec as the variable rec. So this will be the parameter name. And then we are implementing the functionality for our closure function or the anonymous function. In this case, I just want to do split by comma, and the subscripts are mentioned. The subscripts are circular brackets are used to represent the subscripts. Subscripts are represented by circular brackets. In this case, I want to get to the fifth item, and it will start with 0. So I am using 4 here, and then I have to convert to float or double to get the count. In this case, I am converting to float. So for each record, this map function will actually get the fifth element after delimited by comma or after split by comma. It will generate the array, and we are fetching fifth element by subscript 4 dot to float. So this will be the order item subtotal will be the output for each record in our map function. So you can actually get the by applying take function, you can get how many records you want, and then for each I want to print. So I'm using for each function and println, and you can see that it is actually giving the order item subtotal after the transformation done by the map function. Now if I want to add this, I have to use reduce function, and reduce function takes 2 parameters. One is accumulator and the other one is value. So I am naming them as accumulator and value, and here I am giving the functionality for the reduce function, which is accumulator plus value. What will happen is under the covers, Spark will actually add each for each iteration the value will be added to the accumulator, and accumulator will have the final result, and that will be returned. So you can use this and hit enter, and then you will get the result. It is giving in exponential because it is of type float. If you want to actually see the original value, probably you might have to do double instead of float, because the value is too high to be represented as float. Okay, still it is having issue. Dot to double. So this is how you can actually see the actual values. So instead of converting to double, what you can do is you can assign a variable here, val revenue, and then your revenue is of type float. And if you want to see the actual results, you can use printf, which will format the data, and now you can see the actual amount of revenue. It is 34,323,816. So this is how you can actually get your total revenue from the data set. Now another thing which you need to do is the average. So we have got count, we have got total revenue, and now we need to get the average. For that, you need to get the revenue from order items table, and then you have to get the distinct number of orders from the order items table, and you have to divide those two to get the average. So you already have the revenue here, and to get the order items distinct, so let me name as order count equal to order items RDD dot I have to apply map function. The map function will be on rec, or you can actually use underscore without giving the name to the parameter and directly start implementing the functionality. Split comma, and we have to get the second column for the order ID. So if you look at this, this is the field which we are fetching. So we need to get the second column, which is order ID, which can be represented by subscript 1, and I want to convert it into int, and then I would like to get the distinct of them. So there is a action called distinct also. I think distinct is also action. No, distinct is a transformation. So we have to apply an action to execute. After distinct, I want to get the count, and the count will give the distinct number of orders from this table. And you can see that the number of orders from in order items is 57,431. We cannot take it from orders. We cannot just take the count of orders. The reason is there can be orders which might not have order items, especially the cancelled ones. So it might not give the actual result. So for that reason, we need to apply the transformation on order items to get the order IDs, all the unique order IDs, by applying distinct on that, and then you have to apply the count function. So this is what we have done. We have applied the transformation using map to fetch the order ID, and then we got the distinct and then count, and it is 57,431. So order count have the number of unique orders from order items, and revenue have the actual revenue from order items. To get the average, you can just say rev divided by odd count and hit enter. So per order on the average, the revenue is $597. This is how you can get total average from our data set. So we have done count, sum, and average, and also I would like to show you how we can actually get the maximum value from the given data set. So in this case, if I want to fetch the highest priced product from the products table, I can apply the max. I have to implement the maximum functionality on the product price. Similarly, if I want to get which order has generated the highest amount of revenue, I have to apply functionality to get that, or I have to implement that functionality to get the maximum revenue product. So for that, I will take this second example. It's a little bit complicated. As part of our script, it has only the product price, which is relatively simple, but I will try to get by using order items table itself. So I want to get the highest revenue generating order. For that, for each order ID, I has to get the revenue. So let me start doing that. Our orders RDD, sorry, order items RDD is mapped to order items table. I am starting from scratch. sc.text file, user Cloudera, scoop, import, and order underscore items. Okay, and hit enter. Now I want to get order ID and the price. Order ID is the second field from order items table, and so subtotal is the fifth column. So I have to fetch those two fields. For that, I am creating order items map, which takes order items rdd dot map, and the I am passing rec as the parameter, and it returns tuple which include order ID and the revenue for each order item. Okay, so here I have to get rec dot split comma, and then I have to get a second field which is represented by subscript 1. It is of type int, so I am converting to int, and then I want to get the fifth field of which from the array returned by the split function by using comma as delimiter, which is represented by subscript 4, and it is float. So I am actually using float. If you don't change it to float, then it will compare as a string, because the data internally is represented as string, because our each record is alphanumeric. So it is very important to typecast to appropriate data types, and then close it and hit enter. Okay, here I have to define it as val. Hit enter. Now you can actually validate the data. Order items map dot take of 5 dot for each println. For each is another action which will actually get the results for you by applying println on the input RDD. You can see that this is the order ID, this is the revenue for the corresponding order item, which is not which we are not fetching. And if you see, order ID 2 has 3 entries in order items table, and the total revenue for order ID 2 will be the addition of these 3 values, which is approximately $450 and $580. Okay. Now we have to get the sum for each order item. So I am actually using val order revenue per order equal to order items map dot, and here I have to apply advanced transformation called reduce by key, because in this case I want to add by key. I will actually cover by key aggregations later. In this case, just make sure that you have to make sure that you understand that you have to implement by key aggregation, because we have to get the revenue by order. In this case, I am using reduce by key. I will decipher reduce by key as part of future videos. For now, I am just using it so that we can actually get the revenue by key. And it will take 2 parameters, reduce by key, exactly like reduce function, and then here the accumulator and value only work on the second field. By key will take care of grouping by key. You don't need to worry about again applying the transformation on these values. You can just add it directly like this, and it will only add the revenue for each key. Okay, and then close the bracket and hit enter. Okay, I have to just give 1, and then I can say revenue per order dot take of 5 for each println and hit enter. Now you can see that you got only one order ID and then the corresponding revenue for this. Now I want to get the order ID for the highest revenue. So now I have to implement reduce function on this. So revenue per order, I want to first apply map function, and I can apply the reduce function, and in the reduce function it takes two parameters, accumulator and value, and the type of the data type of accumulator and value is tuple, because if you look at revenue per order, take of 5 for each println, you see it is returning tuple. So we have to process each tuple to get the maximum revenue generating order. For that we have to say revenue per order dot reduce, and here it takes two parameters, accumulator and value, and accumulator and value both are tuple, and tuples are represented by underscore notation, not the subscript notation. Hence we have to develop if condition in such a way that we compare the second attribute of the tuple. In this case we have to compare accumulator dot underscore 2, and it does not start with 0, it starts 1. So underscore 1 represents the first one, which is order ID, and underscore 2 represents the second one, and both are tuples, accumulator as well as value both are tuples. Hence we have to compare only on the revenue, which is accumulator underscore dot underscore 2 and value dot underscore 2. If accumulator underscore 2 is greater than or equal to value underscore 2, then we have to return accumulator, else we have to return value, and then we have to close the bracket for the reduce function and hit enter. Now 68,703 is the order which is generating the highest revenue from our data set, and the result is 3,449.91. So this is the highest revenue for the order 68,703. You can easily validate from MySQL. So you can say select order item, order ID, comma, sum of order item subtotal from order items, group by order item, order ID, order by 2, and hit enter. It is going through all the results, and as we have ordered by 2, which is the revenue, the last one is 68,703 with highest revenue $3,449 and some cents, and we got the exact same result by writing our Scala function here. Okay, this is how actually you can implement the total aggregations, not only for sum or average, but also for more complicated aggregations such as max, where you have to have knowledge about Scala coding little bit, and if you are aware of that, you can easily implement these things, and this understanding is required to clear the certification. And as part of the code snippet, here I try to get the maximum priced product from the products table. So if you see, it's the same thing. In this case we don't need to apply reduce by key, because we are not generating anything by key. We are actually doing only we are going through products data only, and we are trying to fetch highest priced product by using product price from our data set. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you have any feedback, please use the comment section of the video. If you want to ask any technical questions related to this, please ask in Stack Overflow, tagging with appropriate tag words. And if you want to discuss further on this, either you can join my LinkedIn group, IT-versity Apache Spark, or IT-versity Hadoop certifications. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you.